Hey guys, welcome to question FM350 of the Further Maths Fortify study guide. This question reads, Maths prodigy Matthew is drawing Venn diagrams. His favourite Venn diagram is shown in the figure below, and then we're given a figure that looks a little bit like this one. We're told that the left circle has a radius of 45 centimetres, the right circle has a radius of 35 centimetres, the right circle's sector angle is 103 degrees. Question A says, what is the value of angle alpha correct to the nearest degree? So we've got to find out this sector angle. So, where we're going to start is first by noticing that we can figure out this length. So, I guess what you would call maybe the width of the sector here, and that they share that same width. So, of course, the actual segments that are attached are different sizes, but the sector, the width of them are the same. So we're going to start off by finding what this length here is, and then we're going to use that. So effectively what we'll do is take that triangle there of 103. In fact, I might even just draw this over to the side. Take the triangle here of 103 degrees there, and 35 centimeters. Figure out what this unknown length is here, and then we'll use that value of A with our other triangle, because if we know what A is, we can figure out what this angle in here is, because we would have these two lengths. So of course we'll be using the cosine rule to find side A, and then once we have side A, a value in here, we can also use the cosine rule, the other variation, to find the angle A. So with that in mind, we'll first start off by finding side length A, which the adjusted formula for finding side length A according to an adjusted cosine rule is the square root of b squared plus c squared minus 2bc times cos of A, and we're looking at this triangle here as we do this. So our first focus is over here to find our value of side A. So in this scenario, B is going to have a value of 35, so we're going to end up with 35 squared plus 35 squared minus 2 times 35 times 35 times cosine of 103 degrees. Now we're going to leave that just like that at the moment. You guys don't have to re-type this out. You could hit enter in your calculators and then use that answer and copy and paste it later on as you needed it. But I'm going to leave it written as this because of course everything we're doing here is by hand. So I'll show you how to do it by hand, but you guys don't feel like you have to type this out every time you want to use it. Just copy it and paste it as you need it. Next we're going to have, now that we have a value for A, we've got a value for this A as well. And that's this expression here. So what we're going to do now is figure out what this angle A is, or alpha. So we know that our rearranged formula for calculating angle with the cosine rule is cos of -1 b squared plus c squared minus a squared all over 2 times b times c. Substituting our known values, we're going to get alpha is going to be equal to, this is where it gets pretty massive by hand, but in this scenario, B is going to be one of these 45s, so 45 squared plus 45 squared minus, and now we're going to insert the value of A that we found before and square it. So I'm going to open a bracket here and then try and put this expression in. So we've got 35 squared plus 35 squared minus 2 times 35 times 35 times cos of 103. So this looks pretty big, but when you break it down, we're just taking this value of A and substituting it in there. All over 2 times 45 times 45. So plugging all of that into a calculator, we should get a value for alpha to the nearest degree of 75 degrees. Part B. Part B says, what is the area in square centimeters of the shaded region in the figure above? round your answer to the nearest square centimeter. So in order to find the area or the shaded area, we are going to need to take the area of our first segment, or a segment. Let's call one of them segment 1. The area of segment 1, and we have to add that to the area of segment 2. So starting with the area of segment 1, and we'll call segment 1 this segment on the left there, which means we're using this sector to find that segment. So the formula for finding the area of a segment is r squared of pi theta over 360 minus half sine theta, half times sine theta. That's our base formula. There should be a multiplication symbol in there, just in case that's confusing any of you. The radius of this first segment is going to be the 35 centimeters, so 35 squared. Pi times our theta for this, or our angle, is 103 degrees, so pi times 103 all over 360. We're going to minus 1 over 2 times sine of 103. And that'll be our expression for the area of segment 1. The area of segment 2, we're going to use the same base formula, so just inserting the values for this other segment on the right, which uses this triangle on the left. So the radius is going to be 45 squared all over pi times, now we found alpha to have a value of 75 degrees before, so this is all over 360, and we can minus 1 on 2 times sine of 75 degrees. Plugging this all in together, so I might even just section this off a bit. The area of the shaded area is going to be equal to 35 squared of pi times 103 all over 360 minus 1 over 2 times sine of 103 plus 45 squared times pi 75 all over 360 minus 1 over 2 times sine 75. Plugging all of that into your calculator and rounding to the nearest whole square centimeter, we should get an answer of 852 centimeters squared. Our diagram then changes a little bit, and we're told that Matthew decides to add a third circle as shown in the figure below, and then we've got a third circle drawn in here. We're told that the smaller circle and the larger circle create an intersection vertical line running from A to B, line AB, so this line here, with a length of 33 centimeters. That's how long that is there. Question C says, what is the value of angle theta correct to the nearest degree? So we're looking at this angle here. So to solve this question, we're going to draw a little triangle that looks like this. We've got a little value for theta in there. We've got 45 and 45. We also know that this line has a value of 33 centimeters. So we can use the cosine rule to figure out angle theta. So our adjusted cosine rule is angle A is equal to arc cos of B squared plus C squared minus A squared all over 2BC. Substituting our known values, we should get that alpha is equal to cos -1 of 45 squared plus 45 squared minus 33 squared all over 2 times 45 times 45. Plugging all of this into a calculator should give you an answer of 43 degrees when rounded to the nearest whole degree. Part D then says, what is the value of R in centimeters? Round your answer to 1 decimal place. So in this question, we're focusing on this other little triangle that we have created. So we have a triangle here, and we know that this angle here is going to be 86 degrees because it's 2 times theta, and theta was 43, so 2 times that was 86. We know that this length here is 33 centimeters, and we've got values of r here. Now we could work out these angles here and then do a bit of rearranging and figure out these values of r, or we can make this a little bit simpler by creating a right angle triangle out of this isosceles triangle. And we know that this angle is going to be 43 degrees because it's going to be half that 86. We know that this length here is going to be half of our 33, so let's call it 33 on 2, and r is what we're trying to find. So this is our hypotenuse. This side is on the opposite side, so we know that we're going to be using our sine equation. So sine theta is going to be equal to opposite over hypotenuse. So substituting our known values, we get sine of 43 degrees is equal to 33 on 2 over r. Rearranging for r, or just solving from here, you'll get r is equal to 33 on 2 all over sine 43 degrees. Plugging that into a calculator and solving to 1 decimal place should give you an answer of 24.2 centimeters for that value of r. Question E says, what is the area in square centimeters of the shaded region in the figure above? Round your answer to the nearest square centimeter. So this question is quite similar to question B, where we're told to find the shaded area, and we're going to find this by adding the area of one segment to the area of the other segment that make up this shape. So in case you can't see it, we have one segment here that comes from this circle, and we have another segment here that comes from the large circle. So that's where our 2 segments are coming on, just in case that wasn't clear. So the area of segment 1 we know that the formula for finding the area of a segment is r squared times pi of theta over 360 minus 1 over 2 times sine theta. Plugging in our values for this first segment here, we're going to have a radius of 45 centimeters, which has an angle here. We found theta before to be 43 centimeters, so this is going to be times 43 over 360 minus 1 over 2 times sine of 43 degrees. So that same value of theta popping up twice, and that's our expression for segment 1. The area of segment 2, we're going to use the exact same base formula, obviously just adjusting for the different values of this second segment. So r in this case, we found that just before to be 24.2, so that's going to be 24.2 squared all over pi times, and our angle that we found for this was 86 degrees, because it was 2 theta, so 86 all over 360 minus 1 on 2 times sine of 86. Plugging that all together, so we get the area, or the shaded area, it's going to be equal to 45 squared times pi times 43 all over 360 minus 1 on 2 times sine 43, so area of segment 1, plus the area of segment 2, which we represent with 24.2 squared pi times 86 over 360 minus 1 on 2 times sine 86. Plugging all of that into a calculator and rounding to the nearest centimeter squared should give you an answer of 217 centimeters squared. We're then given a little more information. We're told Matthew fills in the entire Venn diagram with texture ink as shown in the figure below. Now I haven't filled this in. What I have done is just labeled the angles and the radius measurements that we have found so far. This is just going to help explain what we're going to do here, but of course you guys have your books that you can look at to see the figure that he's talking about there. Question F says, what is the area of the shaded region in the figure above? Round your answer to the nearest square centimeter. So in order to find the area of this Venn diagram, we're going to have to take the area of circle 1, add that to the area of circle 2, and then add that to the area of circle 3. And doesn't matter which these circles are, as long as we just sort of, maybe we'll say 1, 2, 3. Now you might be able to see that we're going to run into a little problem here, because if we take both the area of this circle and the area of this circle, so let's forget about the third circle for a moment there, we're going to have this overlapping region in the middle where we're doubling up on our area. So in order to account for that, we're going to need to remove this the segment pair here, so the segment of circle 1 and the segment that's made by circle 2. And we're also going to do the same thing over here. So after we've added our 3 areas, we're going to have to subtract the area of, and we'll call it segment pair 1. So that'll be this segment pair here. And the area of segment pair 2. Now I've added these together here because it's going to subtract the combined area of those two, and that's exactly what we want. So to break this down a little bit, we know, well, to find the area of circle 1, so we'll treat that as being this circle on the far right here. We're going to use the formula pi r squared, which in this case is just going to be pi 35 squared. The area of circle 2, we're going to use the same formula to find the area of this circle. So this is going to be pi times 45 squared. And the area of circle 3 is going to be pi of 24.2 squared. Now, the area of the segment pair 1 and segment pair 2, we've actually already calculated these two answers in part B and then in part E. So rather than reworking those, we can just jot in those values that we found before. So the area for segment pair 1 we found to be 852 centimeters squared, and the area of segment pair 2 we found to be 217 centimeters squared. So in order to find the area of the whole Venn diagram, we're going to put all this together. So we're going to put pi times 35 squared plus pi times 45 squared plus pi times 24.2 squared, and we're going to subtract 852 plus 217 centimeters to get a whole area of 10,981 centimeters squared when we round to the nearest square centimeter. Question G now asks us, what is the perimeter in centimeters of the entire Venn diagram shown in the figure above? Round your answer to the nearest centimeter. Now this question may appear tricky to begin with, but I promise you it's not as hard as it looks. So our formula for finding the perimeter of this shape is simply going to be the arc length of the sort of the outside circumferences of the circle. Meaning, for example, in this, we called it circle 1 in the last question. So in circle 1, we want to find the arc length from here all the way around to here. And the way that we could do that is by taking this 103 degrees, minusing that from 360, so we're left with whatever this angle is, and then finding the arc length that way. And we can do the same for these two. The slightly more tricky one is going to be this middle circle, because we're going to have to look at what this angle is here and this angle is here and bring them together. But we'll go through how to do that. So in short, our calculation is going to be the arc length of the first circle plus the arc length of the second circle plus the arc length of the third circle. So in order to calculate the arc of the first circle, our formula for this is going to be pi theta over 180. So substituting our values in, pi times, we have a radius of 35. Now our angle, we're going to take 360, which would be the full circle, and subtract from that 103 to be left with whatever's left over. So you can do this calculation if you want. You'll get an answer of 257, but it's not entirely necessary to do that just yet. It's up to you, really. I like to do it like this. So we've got 360 minus 103, leaving us with what's left over, all over 180, and that's our expression for the arc length of the first circle, or the arc that we need. Arc 2, we're going to use this same formula again, so just dropping it in straight away. We're going to do pi times, and this time we've got a radius of 45 degrees. Now this one's a little more tricky, but still very doable. 360 degrees, and we're going to minus this first 75 degrees that we don't need, because we don't need this arc here. And we're also going to minus the 43 degrees here, because we don't need this part of the arc either. So we're going to minus 75 minus 43 to be left with whatever's left over. Now, you could also write this in here. You could write it as 360 minus 75 plus 43, if those 75 and 43 are in brackets, because of course it will combine these numbers first, then subtract them. Here, this is going to take 360 minus 75 from that, and take that answer and minus 43 from that answer. So as long as you understand what's going on there, if you have any questions, drop them in the comments below as always, but otherwise, hopefully that makes sense. All over 180 for arc 2. We're going to take our third arc length. Same formula once again, pi times 24.2 this time, times 360 minus, and this time we're looking at 86 degrees to get rid of. Left with everything outside of that, all over 180. So, putting this all together, the perimeter is going to be equal to pi times 35 times 360 minus 103 all over 180 plus pi times 45 times 360 minus 75 minus 43 all over 180 plus pi times 24.2 times 360 minus 86 all over 180. Whacking all of this into a calculator and rounding to the nearest centimeter, we should get an answer of 463 centimeters for the perimeter of this Venn diagram. Alright guys, that's all the questions from this questions. If you have any questions for us, please drop them in the comments below. Otherwise, I will see you in the next video.